Hey friends, Vincent here. Welcome to VS in Rust, where we make Rust clean and simple. Let's get into it. Today, we are talking about something every serious backend engineer eventually needs to understand: CI/CD pipelines, or more simply, how your code goes from your laptop to production without destroying everything. Now, when people start Rust, they usually think CI means running cargo tests. But production systems are much stricter than that. Modern pipelines are designed to answer one question: can this code be trusted? And that trust is built step by step. Today, I show you the actual CI/CD pipeline I use on RustPulse, my Rust telemetry backend project. No theory, a real pipeline. So let's start with CI, continuous integration. The idea is simple. Every push, every pull request must prove the codebase is still healthy. So here's the trigger right here. This means every change gets verified automatically. No manual checking, no works on my machine. The pipeline becomes the gatekeeper. One small but important detail here is concurrency. This block prevents useless duplicate CI runs. If I push several commits quickly to the same branch, GitHub cancels the older run and keeps only the latest one. That saves time, avoids noise, and makes the CI results easier to trust. Then I defined environment variables. This keeps repeated values centralized. For example, if I need to upgrade SQLx, I change the version in one place, not in every job. The hyped database variables are used by the test environment. In real production environments, secrets should go through GitHub secrets. But for local CI test services, simple test credentials are acceptable. Now, the first stage in my pipeline, right here, is formatting with cargo-llvm-cov. This may sound trivial, it isn't. Formatting consistency matters in teams. And because engineers should spend time reviewing architecture and logic, not spacing and indentation. So RustSMT becomes an automatic style enforcer. Then come Clippy. This is one of Rust's superpowers. Clippy catches bad patterns, unnecessary allocations, questionable APIs, potential bugs, and non-idiomatic Rust. And notice this: warnings are treated as errors, meaning the pipeline fails immediately. That's important because running accumulation slowly destroys code quality over time. Then comes something maybe beginners never think about: cargo deny. This is the dependency auditing. This checks security advisories, duplicates dependencies, license issues, and banned crates. This matters because your application security also depends on your dependencies. Now we move into testing right here in all these ports. So this is where things become more production-oriented. My tests don't run alone. The pipeline actually starts infrastructure. PostgreSQL Redis inside GitHub Actions. This is huge because now tests execute against real services, not mocks pretending to be reality. And that's where many backend bugs appear in real life: networking, database state, serialization, timeouts, and configuration. Now, notice this part. This is a very Rust-specific production safety feature. SQLx validates SQL queries at compile time, but only if metadata is fresh. This command guarantees developers didn't modify queries without updating the SQLx cache. So the CI pipeline protects database correctness too. Now, after test comes coverage with all that part. So code coverage is controversial sometimes. Coverage numbers alone don't guarantee quality, but coverage tooling is still valuable because it reveals untested paths, dead zones, and critical logic never executed. So in RustPulse, I use cargo-llvm-cov right here. And then a HTML report artifact, meaning after the pipeline runs, I can inspect exactly which code paths were tested. Now, this is still only CI. We haven't deployed anything yet. So let's move to CD. Okay, right here on the deployed staging YAML file. So CD continues deployment. This is where things become dangerous because now automation touches servers. For now, my staging deployment pipeline starts manually with a workflow dispatch instruction. And that's intentional. For production systems, you usually want controlled deployments first. Now, here's the important idea. The pipeline does not build directly on the server. Instead, GitHub Actions build a Docker image in the build and push image step right here. Then it pushes it to GitHub Container Registry, GHC here, and then the server simply pulls the image. That's a major architectural difference because now the artifact is immutable and the server receives a pre-built image, not random source code. That dramatically improves reproducibility. Then comes secure SSH deployment on this port. The pipeline writes temporary SSH keys, verifies no host, opens a secure connection, and uploads deployment files. And then remotely restarts the staging services at at that step. There is also a failure debugging step right here. If deployment fails, the pipeline connects to the staging server and prints the last logs from systemd. This is not part of the happy path. It exists for the bad day because when deployments fail, you don't want to SSH manually, search for logs, guess what happened, and waste 30 minutes. So the pipeline gives you immediate context. While the service failed, what crashed, and what configuration was missing. That's a small detail, but it makes the deployment workflow much more practical. Now, here's a detail I really like. After deployment, the pipeline performs a smoke test. This is critical because deployment success does not mean application success. The container may start while the application is completely broken. So, the health endpoint becomes the final verification step. And finally, the part many tutorials ignore completely rollback into that file, rollback staging YAML. My pipeline includes here a dedicated rollback workflow, meaning if a deployment fails, I can redeploy a previous image tag immediately. That matters because real engineering is not never fail. Real engineering is recover fast when failure happens. And honestly, that's one of the biggest mindset shifts in back-end engineering. You stop thinking, how do I avoid all failure? And you start thinking, how do I make failure survivable? Now, let's zoom out. A CI/CD pipeline is not just automation, it's institutionalized discipline. It enforces code quality, testing, security, reproducibility, deployment safety, recovery strategies automatically. Even when developers are tired, even with teams scale, ever under pressure, and Rust fits extremely well into this world because compile time guarantees, strict tooling, dependency management, and deterministic builds all reinforce operational reliability. So if you're learning backend Rust, don't stop at cargo run. Learn the operational side too, because this is where software engineering starts becoming production engineering. Thanks for your time. See you in the next one.